Welcome to today's SANS webcast, Scripting Cloud Security Capabilities. My name is Carol Auth of the SANS Institute, and I'll be moderating today's webcast. Today's featured speaker is Kenneth G. Hartman, candidate for the Master of Science degree in Information Security Engineering from the SANS Technology Institute. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Ken.
Thank you, Carol. Today, I'm going to encourage you to think seriously about formalizing your cloud security capabilities by expressing them as program code. Perhaps you're creating some tools or scripts already. Well, if so, great. My goal then is to encourage you to become even more intentional about it. Although this presentation is heavily focused on Amazon Web Services, the concepts will apply equally well to Google Cloud Platform and Microsoft Azure. My goal with this talk is to encourage you to use the cloud to sharpen your security skills and to do it in such a way as to create a portfolio of security capabilities. In other words, document your security capabilities as program code and improve with each iteration. The next slide talks about security in the cloud, and then I will discuss what is meant by security capabilities. And from there, we'll jump into some examples. Over the past decade, there's been a growing trend where businesses are shifting ever more critical business workloads to the cloud. They find the pay-as-you-go pricing model very attractive, as they only have to pay for the compute, memory, and storage resources they need, and only while they need it. Admittedly, there's some trepidation regarding cloud security still. And this is often rooted in the perceived loss of control over one's data. When starting a discussion on security, I like to set the stage by recalling the defender's goals and the attacker's goals. The defender intends to protect intellectual property, personally identifiable information, and sensitive customer data, making sure that it's available to only authorized users who need to harness this information to the, excuse me, there was a brief cough break. They need to harness this information to the company's advantage. The defender, conversely, the attacker's goal, they want to exploit this data for their own benefit or else diminish it, the value of the data, to the detriment of the data owner. Now, good security increases transparency for those that have a need to know, and the progressive security-conscious cloud providers such as Amazon works very hard to clarify what they're doing to protect your data while it is in their cloud, and also to delineate your security responsibilities as a consumer of their cloud services. And one such example of this is the AWS shared responsibility model. Security capabilities are assets that can be appreciated, and I mean this in both senses of the word. When security capabilities are documented, they become an asset that can grow in value, especially if they are practiced, refined, and evolve as the business changes. This does take investment. However, it's human nature to appreciate things more that require more effort and expense. I strongly believe that anything that is worth doing well. ITIL defines a capability as the ability to carry out an activity, or to steal the catchphrase from the comedian Larry the Cable Guy, to get her done. NIST states that a security capability is a set of mutually reinforcing security controls. Certainly, but I want you to think of capabilities as personal or company assets and to treat them as such. This includes documenting your capabilities. Documentation requires that we step up our game. It requires intentionality, clarity, and perhaps most scary of all, it's something that can get peer reviewed. It was Benjamin Franklin who said, either write something worth reading or do something worth writing. I'm encouraging you to do both. And while I'm at it, I also have to share my personal favorite quote. It's from Tom Peters. He said, do cool shit every day or die trying. Now, thanks to marketing folks who latch onto buzzwords and repeat them until they become meaningless, the important implications of concepts like infrastructure as code can be lost. Others have expanded on the concept of infrastructure as code and started talking about software-defined networking, software-defined data centers, and even data center as code. So when I first proposed this topic, the original title was Cloud Security Capabilities as Code. And this was an attempt to play off the marketing catchphrases. And I was asked, well, Ken, why not just simply cloud security capabilities? So, however, while this talk is a talk about cloud security capabilities, my primary objective is to persuade you, my listeners, to formalize your security capabilities as code and to think of that code as an asset that can be appreciated. Today's cloud services are typically designed as an API, and they expose an object model that can be manipulated programmatically. It also allows for all the object-oriented programming constructs to come into play. For example, abstraction and encapsulation, inheritance, and code reuse, polymorphism. Abstraction and encapsulation are significant to the security professional because it allows us to think in terms of trust boundaries and threat modeling. I'm also very attuned to polymorphism, particularly when someone is trying to use a service for an untested use case. But if we document our security capabilities as code, we can adapt and extend and reuse this code as our processes mature and as the business evolves. Like other code, our security capabilities can also be unit tested and version controlled. The first of the critical security controls that I want to cover is CSC1, Inventory of Authorized and Unauthorized Devices. Security starts with a clear understanding of the scope of what you're tasked to secure. The EC2 inventory.py script that's listed below reads a CSV file that lists the AWS accounts that are in our scope. Our program iterates through each account that's in scope using the appropriate IAM credentials that are configured for that account. And then within each account, it iterates through each region, collecting the details of each EC2 instance. Oh, and EC2 instance is a virtual machine in Amazon Web Services parlance. Iterating through each region was an enhancement that was added later. After all, just because an EC2 instance is supposed to be in a particular region, say US East 1, for example, we cannot necessarily assume that they are. There are multiple data elements that can be obtained by the describe instances command. Among other things, I look for two user-defined tags. One's managed by, and the other is keep until. A different tagging option is to use a ticket number to capture why the instance exists. This ec2 inventory.py script outputs a CSV that can be imported into Excel as a spreadsheet. And this spreadsheet will show the instance name, the internal and external IP addresses, the region, the account that it's in, the age of the EC2 instance, in addition to the two tags that I just mentioned, the managed by and keep until. And now I'm starting to warn users that will terminate any instance that's untagged as an unauthorized device. In the future, I plan to enhance the script to automatically generate an email to the particular user that launched it, letting them know that the instance will be terminated, and possibly even in the future may automatically terminate any untagged instances within 5 minutes of being launched, the thinking that it's not being depended on too heavily by the business within the first 5 minutes. But that's a later stage of maturity. So you can use this concept to list your other virtual devices, such as S3 buckets or security groups, VPCs or elastic load balances, whatever. I like to appropriate the ancient Greek aphorism, know thyself. Also, remember that your security capabilities have to drive organizational change too. The EC2 inventory can highlight untagged instances, but most organizations will have to be cajoled into the discipline of tagging your instances. They may not be ready to use something like the AWS Lambda functionality that can start terminating instances right off the bat. There's a wealth of great information on the internet regarding AWS best practices, complete with examples and tool sets. Some examples of this are Capital One's Cloud Custodian or Netflix's Security Monkey. So rather than compete or contrast with these approaches, I want to highlight them as mature examples of capabilities as code. However, they're not your capabilities until you've taken them and integrated them, tweaked them, and are using them in a business as usual manner. Now, the inventory.py script that I just discussed really isn't all that fancy. There's certainly more impressive examples on the internet, but I would argue that your code should reflect your level of process maturity, and you may be fighting a losing battle if you're trying to skip levels in the capability maturity models phased progression. I suspect that the maturity of Cloud Custodian and Security Monkey closely mirrored their respective organizations' security capabilities in their evolution toward maturity. So while I go on to cover additional code examples, remember that the two most important points I am articulating: one, capabilities can be intentionally matured if documented and integrated into your business as usual processes. And second, the best way to document these capabilities is by doing it as continuously maintained program code. I like to use the EC2 inventory spreadsheet to look at the ages of my company's instances. Very old instances are probably fragile, and that's why they've not been recycled. The whole idea of continuous integration is that you can rapidly provision any instance at a moment's notice. In fact, with Docker, you can get away from patching in place for the most part. Instead, just spawn new patch containers. AWS lets you create an image called an AMI, Amazon Machine Image, from which to launch EC2 instances. This slide contains a link to a sample EC2 hardening script that you can use to bake an EC2 instance. Configure your policies so that users can only launch approved and hardened AMIs and not just any old thing from the AWS marketplace. And I like to use Linus to help me make sure that I have the system hardened to meet the CIS benchmarks. There's the AWS Inspector agent that can be used for Windows, but I found that it doesn't yet support the latest Amazon Linux AMI. There's also AWS Config. AWS Config is a great tool to ensure that your entire AWS environment stays configured as designed. And there's AWS Trusted Advisor, which can verify that you meet the security best practices in your usage of AWS. So I've provided this sample EC2 hardening script because many of the organizations that I've worked with do not have a defined set of requirements for system hardening other than to say, well, it must meet the CIS benchmarks. But I'm arguing that you either need to start from scratch with a script or take a script like mine and make it your own. Define your organization's unique hardening requirements and then bake those in via a hardening script. Iteratively refine this script based on feedback from your risk assessments and your incident handling. So for example, I was recently performing a forensic analysis on an EC2 instance. This effort involved me making a timeline that incorporated syslog events. And when I learned that the default configuration of syslog does not include the year in the timestamp, well, I added that to the backlog of enhancements that will be coming soon for this particular hardening script. To aid with vulnerability assessment, Amazon provides Inspector. And for patching, AWS Systems Manager can be used. Systems Manager is free to use, and AWS Inspector comes with a free trial. And then after that free trial, it's on a per scan basis. The AWS Systems Manager has a feature called Patch Manager that will automate the deployment of patches. As far as vulnerability scanning, another option is Tenable.io, which also has a free trial period. There's also some very good scanners for custom code, and these should be leveraged and integrated into your continuous integration toolchain. So play with this stuff and script it to grow your security capabilities. So on this slide, I've provided a link to a proof of concept that provisions and runs Inspector. This POC script takes the latest Amazon Linux AMI, and then it launches an EC2 instance with the AWS Inspector agent that is installed at boot time. It then proceeds to run a vulnerability scan. And when I ran this script last week, it generated 46 findings that were both medium or highs. So the big takeaway for me was whenever you're launching a new EC2 instance, do not fail to run yum update or whatever the update utility is to make sure that that instance has the latest patches, even at first boot. For my scripts, I typically always have the yum update or whatever the appropriate command is for the operating system as one of the first things I do in the script. But for this one, I have it commented out just so that I actually could find the findings. When an organization has multiple AWS accounts, Amazon recommends that you designate one account to be used for user authentication with a multi-factor authentication token, of course, and then configure roles to be assumed in the other accounts. This is extremely helpful because different roles can be configured for different types of routine and administrative tasks. And then the highly privileged roles are only assumed when needed in a similar manner to sudo or su. So for example, you might configure a role called Manage IAM and then give that to the few people that have the job responsibility of managing the IAM user accounts. You can even configure CloudWatch to send an email alert when one of these privileged roles are assumed. Plus, all activity is captured via CloudTrail, assuming you have it enabled. So on this slide, I provided a proof of concept code that's based on the Amazon tutorial for assuming roles. The Amazon tutorials show how to do various things via the console. So while I'm working through the console examples, such as this particular one, I translate that into a proof of concept script using my own sandbox environment. I found that things that are simple to do with the AWS console may actually take multiple API calls and some figuring out how to translate into a script. But I found that there's huge benefit in being able to spin up and tear down POC environments via script. Amazon and the other cloud providers have tried to make it very easy to play with their technologies. And that's exactly why you should. You need to play with these cloud services in a safe sandbox so that you know how to secure them. Because if you don't, others will play with them in your production environment. Amazon stores the logs generated by their various services in S3 buckets. For example, config or CloudTrail and CloudWatch. These logs can be queried directly by AWS Athena or sucked into Splunk. Splunk has the Splunk for AWS app that even facilitates the ingestion and analysis of these logs. I like to use Splunk for a variety of ad hoc analysis. And even though Splunk can be very expensive in the enterprise, it has a free license if you stay under 500 megabytes per day. And the great thing about the cloud is that you can, when using a script like mine, spin up a Splunk instance to do the analysis and then tear it down multiple times per day. Also, remember that to fully meet CSC 6, you have to analyze and retain the logs from the EC2 instances themselves and not just the AWS environment. Hence, you need to install something like the Splunk Universal Forwarder. So this script actually provisions 2 virtual machines in a new VPC. One is the Splunk indexer, and another Linux system has the Universal Forwarder installed and configured so that it's sending its varlog secure to the Splunk indexer. For me personally, proficiency with Splunk is an important job skill. Therefore, I'm constantly improving and documenting my Splunk searches so that I can improve them. You can certainly use most on-premise anti-malware solutions in the cloud, but if your EC2 instances are short-lived, the anti-malware management portal may become quickly cluttered with agents that are no longer phoning home because the instances were terminated. And this is something where Trend Micro Deep Security actually shines. During the configuration process for Trend Micro, it's granted an IAM role so that it's aware of the configuration of your AWS environment, and then it updates its management portal accordingly. Now, I have no affiliation with Trend Micro or even Amazon for that matter. It's just that deep security is, Deep security is a solution that myself and a few other of the SANS students evaluated as part of a group project. And I was actually very impressed with its ability to integrate with AWS. Smart vendors are following Amazon's lead, and they're offering free trial periods and low-cost elastic pricing so that it's very inexpensive to learn their technology. So Take advantage of these opportunities. There's even an image for Kali in the AWS Marketplace. This makes it easy to spin up a system for an experiment. Just be sure to read the policy regarding pen testing. But that said, the cloud can be a great place to practice your pen testing skills. Spin up a Kali instance and a second target instance. You can even soften the target instance. Just be sure to put it in a security group that can only be reached by the Kali instance. You can script both the attack and the incident response to get a 360-degree view. But again, be sure to read the Amazon policies regarding pen testing and scanning in AWS. You can do it, but there's procedures that need to be followed. The team at Threat Response have made some very cool tools for security in AWS. The AWS IR script automates the imaging of the EC2 instance memory, and it creates a forensic clone of the EBS virtual hard drive. And it does all this after placing it in a security group with a deny all ACL for both the inbound and outbound traffic. So after attacking yourself, you can perform forensics using a virtualized SIFT workstation. So I provided a script to automate the setup of SIFT and instructions on how to attach the evidence that are collected by AWS IR. And one of my main points is that code reuse is a great practice. After all, why reinvent the wheel? And no matter one's level of maturity, the best way to improve is to translate your capabilities into code. It's not enough to expect to use someone else's code. For example, AWS IR, in a moment of crisis, until you've worked with it and have integrated it into your portfolio of security capabilities. After I first became aware of AWS IR and had played with it a few times, well, I thought I might use it in a security incident that had just been called. I was particularly interested in capturing the memory, having just taken the SANS Forensic 508 course. But alas, I didn't have the SSH key to the compromised EC2 instance. And according to the people that I've talked with at Amazon, the only way to capture the memory via a tool, something like AWS IR, is if you have the SSH key. But you don't know this stuff until you practice and drill. There are many security-related service offerings available in the AWS Marketplace. Typically, these have a free trial period or a minimal cost. One of the more expensive ones is Palo Alto Networks at $128 an hour, and that's after their free trial. But hey, $15 for a day's worth of learning and playing, that's a great value. Plus, you terminate the instance and the charges stop. Now, maybe your code is too expensive to put into a public repository on GitHub. Well, if so, use AWS Code Commit. But do commit your code to a code repository of some sort. Take the time to learn how to do this, because the developers in your companies already are, and you should understand their technologies and their tools. Take my scripts and make them better. Play with them and share with me your ideas on how to make them better by making a Git pull request to my repositories. And by the way, all these scripts are on GitHub. Just search for resistor52. That's my GitHub username. So to summarize, the cloud can be secure, but it is not by default. Intellectual property has a shelf life, but capabilities are an appreciable asset. Document your security capabilities as code and use version control as you refine them. Knowing security best practices are not enough. They must be practiced. And it's okay to use someone else's code, but it needs to be fully integrated until it feels like your own. And security capabilities are a competitive differentiator, both for you and your business. Okay, now I'd like to turn it back to Carol for some questions.
All right, thanks for that great presentation. We do have a question for the Q&A. However, if anyone has a question for our presenter, please enter it into the questions window now. Our first question is, can you show us what the output of your EC2 inventory script looks like?
Yes, I actually have that handy. So let me call that up. So this is a redacted example. So I've redacted the owner ID. I've also applied filters so you can show it. So maybe I want to just look at my prod environment, for example. I can select just the prod environment and it will filter it down. I found this to be extremely helpful when dealing with multiple accounts. Like my organization has over 25 that we consider in the scope of what my team is tasked with securing. You can also filter by the running state, or you can look at the age of EC2 instances. And then earlier in the presentation, I had mentioned that one of our requirements is that they tag it with the keep until date and the team who's managing it. So if there's a security incident, we need to know who is the technical owner of that system so that we can contact them for additional information during the course of an incident.
All right, thank you. Does your code have any dependencies?
The EC2 inventory.py script actually uses Python 3, and then there's a SDK for the Amazon called Bodo 3. The other scripts, those are shell scripts, and those have a dependency on the Amazon command line interface. So great question.
All right, well, that's all the questions we have for today. Thank you. Somebody said thanks. Okay. Thank you so much, Ken, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.